In a world moving towards sustainability, engineers are redefining how we design and build. You know, when we think of engineering, we often picture massive structures, complex machines, and incredible innovations. But what if we could make all that greener? That's the big idea behind green engineering. It's not just about adding a solar panel to a building or using a reusable bag. It's a whole new way of thinking, of designing, of creating. It's about looking at the entire life cycle of a product, from the moment we dream it up to the moment it's no longer needed, and making every single step as sustainable as possible. It's about being smarter, more efficient, and more in tune with the world around us. To help guide us on this incredible journey, the U.S. Environmental Protection Agency, or EPA, developed a fantastic framework, the 12 Principles of Green Engineering. Think of them as a blueprint for building a better future. Each principle is a powerful tool in our engineering toolkit, helping us make choices that are good for people and for the planet. This isn't about sacrificing performance for sustainability, it's about achieving both. These principles show us how to create things that are not only effective and innovative, but also responsible. They challenge us to think critically about every material we use, every drop of energy we consume, and every bit of waste we produce. At its heart, green engineering is about working with nature, not against it. For centuries, we've often taken a brute force approach, bending the environment to our will. But nature has been perfecting its own engineering for billions of years, creating closed-loop systems where nothing is wasted. By learning from these natural designs and applying these 12 principles, we can design products and processes that are elegant, efficient, and exist in harmony with our planet's delicate ecosystems. So, grab your safety goggles and let's dive into the 12 principles of green engineering. Let's start with a big one, safety. In traditional engineering, we often deal with hazards by adding on safety features after the fact. Think of a chemical plant with dangerous substances inside. We might add thick walls, warning signs, and emergency shutoff systems. Those are all circumstantial solutions. They manage the danger but don't get rid of it. Green engineering says, what if we could design the danger out from the very beginning? This is the principle of making safety inherent or built in. Instead of using a toxic solvent, could we use water? Instead of a high-pressure reaction, could we find a catalyst that works at room temperature? This is about fundamentally rethinking our processes. It's like designing a car with brakes that are guaranteed to never fail, rather than just adding more seatbelts and airbags. By choosing materials and processes that are intrinsically safe, we eliminate the potential for accidents, spills, and harmful exposures at the source. This not only protects workers and communities but also simplifies the entire system. You don't need as many complex, expensive safety add-ons when the process itself is benign. It's a proactive, intelligent approach to safety that makes our world cleaner and more secure. It's just smarter. You've probably heard the saying, an ounce of prevention is worth a pound of cure. Well, that is the core of our second principle. For a long time, the approach to pollution was to treat it at the end of the pipe. You'd have a factory smokestack, and you'd install a scrubber to capture some of the pollutants before they got out. But green engineering challenges us to prevent the pollution from ever being created in the first place. It's about stopping waste at the source, which is far more efficient and effective than trying to clean it up later. Think about it. Cleaning up is expensive, and it often just moves the pollution from one place to another, like from the air into a solid waste filter that then needs to be landfilled. So how do we do it? We can use high-precision manufacturing techniques, like laser cutting, that create almost no leftover material. We can design chemical reactions that are so efficient, they convert nearly all the starting materials into the desired product, leaving behind minimal byproducts. Another brilliant strategy is creating closed-loop systems, where any waste or byproduct is immediately fed back into the process as a raw material. It's a beautiful, elegant solution that mimics nature. By focusing on prevention, we save resources, reduce costs, and protect our environment all at once. We're not just managing waste, we're designing it out of existence. Have you ever tried to take apart a modern electronic device? It can be a nightmare of weird screws, glued together parts, and a dozen different types of plastic all fused together. When a product is hard to take apart, it's almost impossible to repair or recycle effectively. Most of it just ends up in a landfill. That's where our third principle comes in: design for separation. This means we should design products from the very beginning with their end of life in mind. It's about making disassembly as easy as assembly. Just think of building blocks. They snap together, and they pull apart, ready to be used again. This involves making smart, simple choices. We can use modular components that can be easily swapped out for repairs or upgrades instead of having to throw the whole thing away. We can use standardized fasteners, like common screws instead of proprietary glue, so that anyone with a basic toolkit can take the product apart. It also means being mindful of the materials we use, keeping them separate and easy to sort. For example, instead of fusing plastic and metal together, we can design them to snap apart cleanly. By designing for separation, we unlock the true potential of the circular economy, making recycling, remanufacturing, and reuse the easy choice, not the difficult one. Efficiency is a word we hear a lot, but what does it really mean in green engineering? Well, it means getting the absolute most out of everything we put into a system. Every bit of energy, every gram of material, every square meter of space, none of it should go to waste. This is the fourth principle: maximize efficiency. It's about being incredibly precise and intentional with our resources. Think of it like a master chef who uses every part of a vegetable, from the root to the leaf, creating a delicious meal with zero waste. Engineers can apply that same philosophy to everything they design. For instance, in many industrial systems, pumps and motors run at full power all the time, even when they don't need to. That's like leaving your car engine revving at a red light. A green design would use load-sensing pumps that automatically adjust their power based on the immediate demand, saving enormous amounts of energy. In chemistry, it means designing reactions that happen at lower temperatures and pressures, reducing the energy needed to make them go. It's also about the efficiency of space, designing buildings and factories that are compact and well-organized to minimize land use and the energy needed for heating, cooling, and transport. Maximizing efficiency isn't just about saving money, it's a fundamental sign of intelligent, elegant design. Let's talk about supply and demand. For decades, the dominant model in manufacturing has been input pushed. Companies would forecast how much of a product people might want, produce a massive batch of it, and then push it onto the market. The problem? Forecasts are often wrong. This leads to overproduction, warehouses full of unsold goods, and eventually, a tremendous amount of waste. Our fifth principle flips this model on its head. It's about creating output-pulled systems, also known as just-in-time or on-demand manufacturing. In an output-pulled system, you don't make anything until there's a real, confirmed demand for it. It's a system that responds instead of predicts. Think of a 3D printer that only creates an object when someone places an order, or a smart power grid that generates more electricity only when people start turning on their air conditioners. This is made possible by modern technology. Sensors, data analytics, and automation allow systems to monitor real-time demand and adjust their production accordingly. This minimizes the waste of energy, raw materials, and human effort associated with making things that nobody ends up using. It's a lean, agile, and incredibly sustainable way to operate. When we build something, where is most of the value? Where is the energy, the research, the intricate manufacturing? It's usually in the most complex components. Think about your car. The engine is an incredibly complex piece of machinery, the result of millions of hours of design and manufacturing. The tires, on the other hand, are relatively simple. Our sixth principle, Conserve Complexity, tells us to protect and preserve that embedded value for as long as possible. Instead of throwing away the whole complex product when one small part fails or becomes outdated, we should design it to be maintained and upgraded. This is the opposite of planned obsolescence. It means designing that car engine to be easily remanufactured, taken apart, cleaned, fitted with new parts, and put back into service, as good as new. It means designing a smartphone so that the processor or camera, the most complex parts, can be upgraded without having to junk the entire device. By focusing on conserving complexity, we keep those high-value, resource-intensive components in the economic loop for as long as possible. we reduce the need to mine new materials and expend huge amounts of energy to manufacture new complex parts from scratch. It's a powerful strategy for preserving value and minimizing our environmental footprint. This next principle might sound a bit counterintuitive. Shouldn't we make everything last forever? Well, not exactly. The seventh principle is durability rather than immortality. This means we should design a product to last for its intended useful lifespan, but not necessarily forever. After its job is done, it should be able to disappear gracefully, either by biodegrading back into the earth or by being easily recycled into something new. Think about it. A disposable coffee cup doesn't need to be made of a plastic that will last for 500 years. That's designing for immortality when all you need is durability for about 30 minutes. The key is matching the product's lifespan to its function. For something like the foundation of a bridge, you want extreme durability. It should last for centuries. But for food packaging, you want it to protect the food and then break down quickly and safely once it's empty. This is where innovations in material science are so exciting. We can create bio-based plastics that are strong and durable during use, but will compost in a few months. By designing for an appropriate, planned end of life, we prevent the buildup of immortal trash in our landfills and oceans. It's about designing things to be useful while they're here, and to not be a problem when they're gone. In the world of engineering, there's often a temptation to over-engineer things, to make them bigger, stronger, or more feature-packed than they really need to be. This is known as over-design, and it's a huge source of waste. Our eighth principle, meet need, minimize excess, is a direct challenge to this mindset. It pushes us to design products and systems that meet their functional requirements precisely, without adding unnecessary material, energy, or complexity. It's about asking, what is the core function this thing needs to perform? And then achieving that in the most elegant and resource-efficient way possible. A classic example is in packaging. How many times have you received a tiny item in a giant box filled with plastic pillows? That's a failure to meet need and minimize excess. A green engineering approach would be to create custom-fit packaging that uses the absolute minimum amount of material needed to protect the product. In construction, it could mean using advanced modeling software to calculate the exact amount of steel needed for a building's frame, instead of just using oversized beams to be safe. This principle isn't about making things cheap or weak. It's about being intelligent and precise, eliminating waste by design and ensuring every bit of material serves a real purpose. Let's go back to the recycling plant. Imagine a conveyor belt piled high with products. If each product is made of 20 different types of plastics, metals, and composites all bonded together, sorting them for recycling is a nearly impossible task. Most of that material will end up being contaminated and landfilled. This brings us to our ninth principle, minimize material diversity. This means that whenever possible, we should design products using the fewest number of different materials. Better yet, we should try to make the entire product out of a single material, or from materials that are very easy to separate. Consider a simple plastic bottle. The bottle, the cap, and the label are often made from 3 different types of plastic. This complicates recycling. A greener design might use the same type of recyclable plastic for both the bottle and the cap, and use a label made of a compatible material or even print directly onto the bottle with a washable ink. By simplifying the material palette, we make the recycling process dramatically easier, more efficient, and more economically viable. It increases the chances that the materials will actually be recovered and turned into high-quality new products, closing the loop and reducing our reliance on virgin resources. It's a simple idea, with a huge impact. In nature, there's really no such thing as waste. The fallen leaves from a tree decompose and become nutrients for the soil, which in turn feeds the tree. It's a perfect, closed-loop system. Our 10th principle, integrate material and energy flows, encourages us to mimic this natural wisdom in our industrial systems. This means designing processes so that the waste from one step, whether it's excess heat, a chemical byproduct, or leftover material, becomes a valuable input for another step. It's the ultimate form of recycling, happening in real time, right inside the factory walls. Imagine a power plant that generates electricity. It also produces a massive amount of waste heat. Instead of just venting that heat into the atmosphere, we can capture it and pipe it to a nearby greenhouse to grow vegetables, or use it to heat homes and offices in the community. This is called cogeneration, or combined heat and power. Or, think of a brewery, where the spent grains left over from the brewing process can be used as a high-protein feed for local livestock, or as a raw material to make bread or biofuels. By intelligently linking different processes together, we can create industrial ecosystems where everything is used and nothing is wasted, dramatically increasing overall efficiency and reducing our environmental impact. What happens to a product when its first owner is done with it? Too often, the answer is the trash can. Our 11th principle, designed for commercial afterlife, challenges us to think beyond the first use. It means designing products with a plan for their second, third, or even fourth life. This isn't just about recycling the raw materials, it's about preserving the product's value and function for as long as possible through reuse, refurbishment, and remanufacturing. It's about seeing used products not as garbage, but as assets for future commerce. For example, companies can design industrial equipment to be easily returned, refurbished with the latest technology, and then resold or leased to another customer. This is common with things like medical imaging machines and large-scale printers. On a consumer level, it means designing furniture that can be easily reupholstered or refinished, or clothing that is durable enough to be resold in a thriving second-hand market. It requires a shift in business models, from just selling a product once to providing a service or managing the product's entire life cycle. By planning for a commercial afterlife from the start, companies can create new revenue streams, build customer loyalty, and play a key role in a truly circular economy. Our final principle is perhaps the most fundamental of all: renewable rather than depleting. For much of human history, our progress has been fueled by depleting resources, things we can only use once, like coal, oil, and natural gas, and minerals that we mine from the earth. These resources are finite. Once they're gone, and using them has significant environmental consequences. This principle urges us to shift our reliance toward resources that are renewable, those that nature can replenish, or that are essentially inexhaustible. This means prioritizing renewable energy sources like solar, wind, geothermal, and hydropower. These technologies harness the power of the sun, the wind, and the earth itself, providing clean energy without depleting finite fuels. On the material side, it means innovating with bio-based resources. Instead of making plastics from petroleum, we can make them from corn, sugarcane, or even algae. We can build with sustainably harvested wood instead of energy-intensive concrete and steel. By choosing renewable inputs for both our energy and our materials, we build a system that can truly be sustained for generations to come. We break our dependence on depleting resources and create a foundation for a resilient and thriving future. So there you have it, the 12 principles of green engineering. From designing out danger and preventing pollution at the source, to maximizing efficiency and planning for a product's afterlife, these principles provide a comprehensive and powerful roadmap. They are not just separate ideas, but an interconnected philosophy for creation. They show us that by thinking about the entire life cycle of what we make, we can build a world where human ingenuity doesn't come at the expense of our planet. These principles are the very foundation of a smarter, more responsible way of making things, turning challenges into opportunities for innovation. This is what true progress looks like. It's not just about bigger, faster, and more powerful. It's about building smarter, cleaner, and more sustainable technologies that improve our lives while respecting and protecting our natural world. Green engineering proves that we can have both economic vitality and a healthy environment. It's about creating elegant solutions that are efficient, safe, and circular by design. By embracing this mindset, we move from being consumers of the planet's resources to becoming stewards of them, ensuring that future generations have the same opportunities that we do. The future is not something that just happens to us, it's something we build. The power to create this sustainable future is in our hands. It's in the hands of the engineers designing the next generation of products, the business leaders choosing sustainable practices, and in all of us as consumers demanding better, greener options. Every choice we make is a vote for the kind of world we want to live in. So let's get to work. Let's be curious, let's be creative, and let's be bold. Let's innovate for a thriving planet. Thank you for watching.